Dear viewers and students, आज हमारे कोर्स कैल 2 का 11वां लेक्चर है। इससे पहले लेक्चर में हमने वेक्टर्स की इब्तदाई बातें की। आज के लेक्चर में हम वेक्टर्स का एक और कंसेप्ट करेंगे और इसके अलावा डायरेक्शनल डेरिवेटिव्स का टॉपिक पढ़ेंगे। अगर हमारे पास 3 वेक्टर्स हों तो उसमें हम प्रोडक्ट कैसे करें। इस वक्त जो हम प्रोडक्ट डिफाइन कर रहे हैं उसमें 2 वेक्टर्स की हम क्रॉस प्रोडक्ट लेंगे जो कि एक वेक्टर होगा और उसको तीसरे वेक्टर के साथ हम उसकी डॉट प्रोडक्ट लेंगे। अल्टीमेटली रिजल्ट स्केलर होगा, इसलिए ये प्रोडक्ट स्केलर ट्रिपल प्रोडक्ट कहलाती है। देखते हैं कि कैसे है। Its magnitude is given by, we have 3 vectors A, B and C. So that is A cross B first, then dot B, and the magnitude of that is equal to magnitude of A cross B into magnitude of C into cosine of theta between the vector obtained by A cross B and the vector C. This is also known as box product because here we have a parallelepiped, and if we find the magnitude of this scalar triple product, in fact we are evaluating the volume of parallelepiped. What is parallelepiped? डायग्राम में देखते हैं। यहां पर हमारे पास एक ये टेढ़ा सा डब्बा है। अगर ये बिल्कुल इसके तमाम एजेस राइट एंगल पर हों तो ये क्यूब टाइप बन जाता है, लेकिन इसमें हमारे पास जो ये फिगर हमारे पास सामने नजर आ रही है इसके 3 एडजेसेंट साइड्स हैं, OA, OB and OC. So if we represent the vector A by OA and the vector small b by OB and the vector small c by OC, so we are interested to find A cross B and then dot C. You see here that as we have discussed in our previous lecture that A cross B is the area of the parallelogram, the area of the base, and C, if we multiply this vector by C scalarly, then we will be getting this magnitude of A cross B into magnitude of C into cosine of theta. Now C cosine theta will give you the height of this parallelepiped, and we know from elementary geometry that area of the base multiplied by the height of the parallelepiped gives us the volume of this parallelepiped. So this triple scalar product gives us the volume. Here we know that dot product is commutative, so we can do A cross B dot C or C dot A cross B. And even if we change this order just like this, B cross C dot A and C cross A dot B, even then these quantities will be equal if we take the magnitude, the positive value of this. So these all will be equal. Now, as in the case of scalar product and cross product of two vectors, we have given the formula in the rectangular components form. So we give the method and formula for finding the scalar triple product in components form. Let us do that. We have vector A is equal to A1i plus A2j plus A3k, and vector B is equal to B1i plus B2j plus B3k, and the vector C is equal to C1i plus C2j plus C3k. Then the scalar triple product, which is A dot B cross C. So this B cross C we will determine by the determinant formula. So it will become A dot determinant whose first row is ijk, second row is B1, B2, B3, and third row C1, C2, C3. And we are evaluating this determinant, so which will be equal to B2, C3, C2, C3 determinant I minus B1, B3, C1, C3 determinant j, B1, B2, C1, C2 determinant k. So this will be a vector, and we are multiplying this vector by a scalar multiplication, A dot into this vector, and that is equal to A1 into determinant B2, B3, C2, C3 minus A2 into determinant B1, B3, C1, C3 plus A3 into determinant B1, B2, C1, C2, which is equal to the determinant whose first row is A1, A2, A3, B1, B2, B3, C1, C2, C3. So we see by this method finding scalar triple product is very easy. Just you construct a determinant with the coefficient of these vectors. If the order is changed, maybe the sign is changed, but if you are only interested finding the magnitude, that is the volume, then it does not matter. You always take the positive sign. हमने ये स्केलर ट्रिपल प्रोडक्ट का फार्मूला किया, उसका फार्मूला देखा. इसके लिए हम कोई एग्जाम्पल भी करते हैं कि अगर हमारे पास तीन वेक्टर्स मौजूद हों तो उनकी स्केलर ट्रिपल प्रोडक्ट हम कैसे निकालते हैं. इस एग्जाम्पल में द वेक्टर A इज इक्वल टू I प्लस 2j माइनस k, द वेक्टर B इज इक्वल टू माइनस 2I प्लस 3k, द वेक्टर C इज इक्वल टू 7j माइनस 4k. So triple scalar product A dot B cross C becomes equal to determinant whose first row is the coefficient of ijk from A, which is 1, 2, minus 1, and second row is from the coefficients of ijk of the vector B. So that is minus 2, 0, 3, because j term is not there, and the third row similarly is 0, 7, minus 4. We evaluate this determinant, and it is easy to evaluate, and the result is equal to minus 23. So, and that will be the, in fact, if we consider the volume of the parallelepiped whose adjacent sides are given by the vectors a, b and c, so that will be equal to the magnitude of this, that is, I mean, only take the absolute value of this, so which is equal to 23. अब हम एक और वेक्टर की बात करते हैं which is called gradient of a certain function. What is gradient? In fact, it is an operator denoted by del, and it is applied on a function. In our this very first discussion, this function will be a scalar function, I mean real valued function. What is this operator? Let us see. Del is I partial derivative with respect to x plus j partial derivative with respect to y plus k partial derivative with respect to z. This will be a operator. If we apply it on a certain function, say phi, so del phi mean we are operating the operator del on phi. So del phi will be equal to I partial derivative of the function phi with respect to x plus j partial derivative of y partial derivative of phi with respect to y plus k into partial derivative of phi with respect to z. So this will be del phi, and this del phi will be called gradient of the function phi. ये जो हमने कंसेप्ट्स जितने वेक्टर्स के किए और ये जो अभी हमने बात की, इनकी हम एप्लीकेशन हम अपनी कैलकुलस में चाहते हैं. अब जो हम टॉपिक कर रहे हैं उसका नाम है डायरेक्शनल डेरिवेटिव्स. अगर फंक्शन ज्यादा वेरिएबल का है तो हम उसके पार्शियल डेरिवेटिव्स मालूम करते हैं विद रिस्पेक्ट टू ईच वेरिएबल कीपिंग अदर कांस्टेंट. If we take the function of two variable, that is z is equal to function of xy, we know that the partial derivative of the function with respect to x is the derivative in the direction of x-axis, and partial derivative of the function with respect to y is the derivative rate of change of the function along the direction of y. सवाल ये पैदा होता है कि क्या हम इन्हीं दो डायरेक्शन के अलोंग किसी फंक्शन की रेट ऑफ चेंज देख सकते हैं, जबकि प्लेन में तो इनफाइनाइट डायरेक्शन हो सकती हैं. इसका जवाब मस्बत में है कि हां, हम किसी और डायरेक्शन में भी फंक्शन की रेट ऑफ चेंज को देख सकते हैं. सपोज कि हमारे पास कोई फंक्शन z इज इक्वल टू एफ एक्स वाई है और उसकी रेट ऑफ चेंज हम किसी गिवन डायरेक्शन में देखना चाहते हैं. गिवन डायरेक्शन से मेरा मतलब यह है कि यहां पर हमें कोई वेक्टर्स दिया हो कंपोनेंट की डायरेक्शन में, कंपोनेंट की फॉर्म में अगर हमारे पास ये वेक्टर्स कोई मालूम हो और हम चाहते हो कि हम इस फंक्शन का रेट ऑफ चेंज इस वेक्टर की डायरेक्शन में देखें। तो इसके लिए हम एक तो जो वेक्टर जिसकी डायरेक्शन में हमने डेरिवेटिव मालूम करना है उसका यूनिट वेक्टर मालूम करेंगे। फर्ज कर लिए उसके यूनिट वेक्टर के कंपोनेंट्स u1 और u2 हैं, और जो फंक्शन है उसके हम पार्शियल डेरिवेटिव विद रिस्पेक्ट टू x और पार्शियल डेरिवेटिव विद रिस्पेक्ट टू y मालूम करेंगे। और अगर गिवन पॉइंट है तो वो गिवन पॉइंट की वैल्यूज पुट करके उनकी वैल्यूज मालूम करेंगे। इन पार्शियल डेरिवेटिव ऑफ विद रिस्पेक्ट टू x को u1 से मल्टीप्लाई करेंगे और पार्शियल डेरिवेटिव ऑफ द फंक्शन विद रिस्पेक्ट टू y को u2 से मल्टीप्लाई करेंगे और इसका सम लेंगे। ये जो क्वांटिटी आएगी एक स्केलर क्वांटिटी होगी, और ये हमारे पास इस फंक्शन का इस डायरेक्शन में डायरेक्शनल डेरिवेटिव कहलाएगा एट दैट पॉइंट। जानते हैं आपके मैथमेटिक्स है तो ये ज़बानी तो समझ में आने वाली बात नहीं है, सो बेहतर है कि हम इसको लिख के देखते हैं। आइए, डायरेक्शनल डेरिवेटिव। इफ एफ एक्स वाई इज ए डिफरेंशिएबल at the point x0 y0 and if u is equal to u1 u2 is a unit vector, then the directional derivative of f at the point x0 y0 in the direction of u is defined by, that is equal to fx x0 y0 into u1 plus fy x0 y0 into u2, as I have already said, and the notation for it is d of fx0 y0 and d subscript u. This u stands that our directional derivative is along the direction of the unit vector u, and its value is evaluated at the point x0 y0. It should be kept in mind that there are infinitely many directional derivative of the function z is equal to fxy at a point x0 y0, one for each possible choice of the direction vector u. इस डायरेक्शनल डेरिवेटिव को हम ज्योमेट्रिकली कैसे देखते हैं, फिर हम डायग्राम और फिगर पर चलते हैं। ये सामने आपके डायग्राम है। z इज इक्वल टू एफ एक्स वाई, ये शेडेड जो है ये सरफेस है, और हमारे पास एक्स वाई प्लेन में एक वेक्टर u है। सो हमने इस पॉइंट पर जिसके के कोऑर्डिनेट x0 y0 एक्स वाई प्लेन में है और इसका z0 कोऑर्डिनेट that is just above on this point, and the point is Q0 here. So if we draw a plane containing this vector u and meeting the surface z is equal to fxy, this plane will meet this surface in a curve. You can see there is a curve. So, and we have drawn a tangent there. So our this directional derivative will be along this curve. At the point Q0, it will be the slope of this tangent. So you can see in the figure here that in our partial derivative with respect to x, we have these curve when there is a intersection of the plane y is equal to y0 constant plane with the surface, and partial derivative with respect to y when we have our constant plane x is equal to x naught, and when this plane meet the surface and producing a curve. But here we have any direction u in xy plane, and this plane is meeting the surface in the curve. So the rate of change of our function along this curve will give us the directional derivative of this function at the point x naught, y naught. Algebraically, we say the directional derivative d of f x naught y naught in the direction of u can be interpreted as the instantaneous rate of change in the direction of u at x naught y naught of z is equal to fxy with respect to the distance parameter s described above, or geometrically as the rise over the run of the tangent line to the curve C at the point Q naught. अब हम इस पर दो एग्जाम्पल करते हैं ताकि हमें इसकी एप्लीकेशन पता चल सके और इसको सही तरीके से कैलकुलेट करना आए. आइए एग्जाम्पल करते हैं. Our function is fxy is equal to 3x square y, and we want to find the directional derivative of this function at the point 1, 2 in the direction of the vector a is equal to 3i plus 4j. Now we find partial derivative of f with respect to x, which is equal to 6xy, and partial derivative of the function with respect to y, which is equal to 3x square, so that their respective values are 12 and 3. The direction which we have, that is the vector a, 3i plus 4j. First of all, we will find the unit vector along this vector. The magnitude of the vector a is 5, so we will divide it by 5. So the unit vector along the direction of a, that is a cap, is equal to 3 or 5i plus 4 or 5j. And using our definition, the directional derivative of the function at the point 1, 2 in the direction of vector a is equal to 12 into 3 over 5 plus 3 into 4 over 5 is equal to 48 over 5. और अब हम अपनी दूसरी एग्जाम्पल करते हैं. आइए एक और एग्जाम्पल. फंक्शन fxy is equal to 2x square plus y square, and the given point is p naught having coordinate -1, 1, and the given direction is the vector u, which is equal to 3i minus 4j. To find the unit vector along this direction, we find the magnitude of u, which is equal to 5. So the unit vector along the vector u cap, is equal to 3 over 5 I minus 4 over 5 j. Fx, the partial derivative of the function with respect to x, is equal to 4x, and its value at the point -1, 1 is -4. Fy, the partial derivative of the function with respect to y, is 2y, and its value at the point -1, 1 is equal to 2. So according to our rule, this will be equal to fx into u1 plus fy into u2 at the point -1, 1, and this will be equal to -12 over 5 minus 8 over 5 is equal to -4. यूनिट वेक्टर, आप जानते हैं कि यूनिट वेक्टर का मैग्नीट्यूड 1 होता है. अगर यूनिट वेक्टर के दोनों कंपोनेंट एक u1 और u2 I mean u1 along x-axis, u2 along y-axis है, तो what will be u1? u1 always equal to cosine of theta, and u2 is always equal to sine of theta. What is that theta? This theta is the angle which the vector makes with the x-axis. So in place of u1 and u2, we can use cosine theta and sine theta in our definition if we are given the angle of the vector which is making with the x-axis. ये आप ये कह लीजिए कि अगर हमारे पास वेक्टर्स रेक्टेंगुलर कंपोनेंट्स फॉर्म में दे रखे हों तो वो पहला फार्मूला है, लेकिन अगर हमारे पास वेक्टर का एंगल दे रखा हो एक्स एक्सिस के साथ, तब हमारे पास फार्मूला जो है वो इस किस्म से बन जाएगा कि एफ एक्स इंटू कोसाइन थीटा प्लस एफ वाई इंटू साइन थीटा। तो इसकी भी एग्जाम्पल हम कोई करते हैं। चलिए हम एक एग्जाम्पल करते हैं। वी हैव फंक्शन हियर एफ एक्स वाई इज इक्वल टू e raised to power xy, and we want to find the directional derivative at the point minus 2, 0 in the direction of the unit vector u that makes an angle of pi by 3 radians with the positive direction of x-axis. So first of all we find the partial derivatives, which will be equal to fx is equal to y e raised to power xy. As you know, I recall you, the derivative of e raised to power xy is equal to e raised to power xy into derivative of xy with respect to x, keeping y constant. So that will be equal to y. So this derivative is equal to y into e raised to power xy. Similarly, partial derivative of the function with respect to y is equal to x into e raised to power xy, and their values at the point minus 2, 0 is equal to, we can easily calculate fx is equal to 0 and fy will be equal to minus 2, and the angle is pi by 3, so we need cosine of pi by 3 and sine of pi by 3. We know cosine of pi by 3 is 1 by 2 and sine of pi by 3 is square root 3 divided by 2. So the directional derivative of the function at the point minus 2, 0 in the direction of the unit vector u is equal to 0 into 1 by 2 plus minus 2 into square root 3 by 2, which ultimately equal to minus square root of 3. Gradient of the function, we have already mentioned it, we have already defined it, that for a certain function f, del phi will be called the gradient of the function, and which is equal to partial derivative of the function with respect to x. This is a component in the I direction, and partial derivative of the function with respect to y, this will be component in y direction. So this called del f, the gradient of the function. We can use this gradient of the function for evaluating our directional derivatives. So if we have a vector u or the unit vector along a certain directions, and we want to find the directional derivative in that direction, whose unit vector is u1i plus u2j. So from the definition, it is very easy to say that this is the dot product of gradient phi and the unit vector u. Let us see all these things in the written form on the screen. So here, directional derivative of xy in the direction of u is equal to del of f. It means gradient of the function, and dot unit vector in the direction of u. So we have got another method to find the directional derivative. Let us do an example using this second method. So we do the example. In the example, we have a function here, that is fxy is equal to 2xy minus 3y square, and the point is p0, whose coordinates are phi 5. We want to find the directional derivative of this function at this point in the direction of the vector u, which is equal to 4i plus 3j. So first of all, we will find the unit vector along this direction, which will be equal to u cap is equal to 4 over 5i plus 3 over 5j, and fx mean the partial derivative of the function with respect to x, which is 2y, and partial derivative of the function with respect to y, which is 2x minus 6y, and their values at the point phi 5, which are 10 and minus 20 respectively. So del f is the vector 10i minus 20j, and now we will find the dot product, the scalar product of this vector del f and the unit vector u cap. So the directional derivative of the function at the point phi 5 in the direction of the vector u is equal to del f dot u cap, which is equal to 10 into 4 over 5 minus 20 into 3 over 5, and the calculation will give you that is equal to minus 4. डायरेक्शनल डेरिवेटिव्स के लिए एक और एग्जांपल करते हैं. ये एग्जांपल थोड़ी सी मुख्तलिफ इस तरीके से है कि इसमें ट्रिग्नोमेट्रिक फंक्शन भी इन्वॉल्व है और एक्सपोनेंशियल फंक्शन भी इन्वॉल्व है. तो एक और एग्जांपल करते हैं. फंक्शन हमारे पास यहां है एफ एक्स वाई इज इक्वल टू एक्स ई वाई प्लस कॉस एक्स वाई, and we are finding the directional derivative of this function at the point 2 0 in the direction of vector a is equal to 3i minus 4j. First we calculate the unit vector along the direction of a. Let us call it u cap. So the magnitude of vector a is equal to 5. So this unit vector is equal to 3 over 5i minus 4 over 5j. Now the finding the partial derivatives, fx, which is equal to e raised to power y minus y sine xy, and fy, which is equal to x ey minus x sine xy, and their values at the point 2 0, putting at for x is equal to 2 and y is equal to 0, the partial derivative fx becomes e raised to power 0 minus 0, which is equal to 1. and partial derivative with respect to y becomes 2 into E0 minus 2 into 0, which is equal to 2. The gradient of f at 2, 0 will be fx20 I plus fy20 j, so that is equal to the vector I plus 2j. The directional derivative of f at 2, 0 in the direction of A is therefore directional derivative of f at the point 2, 0 in the direction of u is equal to del f dot u, which is equal to I plus 2j dot 3 over 5 I minus 4 over 5j, which is equal to 3 over 5 minus 8 over 5 is equal to minus 1. डायरेक्शनल डेरिवेटिव्स की कुछ प्रॉपर्टीज भी हैं और जाहिर है कि हम इंटरेस्टेड होंगे इस बात में कि कोई फंक्शन अगर चेंज हो रही है उसमें तो किस डायरेक्शन में सबसे ज्यादा चेंज हो रही है और किस डायरेक्शन में सबसे कम चेंज हो रही है या किस डायरेक्शन में बिल्कुल कोई चेंज नहीं हो रही, क्योंकि डायरेक्शनल डेरिवेटिव्स हमें किसी डायरेक्शन में रेट ऑफ चेंज देते हैं फंक्शन का। जैसे कि हमने अभी डिफाइन किया कि किसी फंक्शन का डायरेक्शनल डेरिवेटिव इनफैक्ट उस फंक्शन के ग्रेडियंट के वेक्टर का और जिस डायरेक्शन में हमने मालूम करना हो उसके यूनिट वेक्टर का डॉट प्रोडक्ट होता है। इफ वी डिनोट ग्रेडियंट ऑफ एफ बाई डेल एफ एंड यूनिट वेक्टर बाई यू कैप, सो द डायरेक्शनल डेरिवेटिव ऑफ एफ in the direction of u is del f dot u cap. Now we know by the definition of the dot product that is equal to magnitude of del f into magnitude of u cap into cosine of angle in between them. Because the magnitude of the unit vector is 1, so this will be equal to the scalar quantity magnitude of delta f into cosine of theta, where theta is the angle between the vector u and the vector delta f. So this is a scalar quantity which is the product of magnitude of del f and cosine theta. So this is the quantity on the right hand side on which we will talk. When this quantity is maximum, we know that cosine theta varies from -1 to 1. So the maximum value of cosine theta is 1 and the minimum value of cosine theta is -1. So where the cosine theta is 1, the angle is 0. So therefore this quantity is maximum when theta is 0. In other words, when our this gradient f is in the direction of the vector u, and when it is minimum when theta is 180 degree. So in that case cos theta is equal to -1, so that will be equal to minus magnitude of delta f. Now where it is minimum, if theta is pi by 2 or our this unit vector is orthogonal to the gradient, then cosine theta is equal to 0. So in this case the result will be 0. So we will say that there will be no change in these directions. So the directional derivative in the direction orthogonal to the of the gradient of the function is 0. So we can say that the function does not change in the direction where the direction is perpendicular to the gradient of the function. For this we will be doing a couple of examples for finding that where the directional derivatives, the value of the directional derivative is maximum, where is minimum, and where there is no change. Let us do some example. Our function is fxy is equal to x square by 2 plus y square by 2. First of all, we find the direction in which there is a rapid change, I mean maximum change. As we have discussed, the function increases most rapidly in the direction of del f at the point 1, 1. The gradient is value of del f at the point 1, 1, and that will be x plus yj at 1, 1, and which is equal to I plus j. For direction, we will find the unit vector along these directions, and the unit vector along these directions will be equal to I plus j divided by the magnitude of I plus j. The magnitude is square root 2, so that is the vector 1 over square root 2i plus 1 over square root 2j. Next, the direction of rapid decrease. Definitely it is the opposite of the direction of gradient of f. So that is minus of this direction, and minus this direction will be equal to minus 1 over square root 2i minus 1 over square root 2j. Now the direction where is no change, where is zero change, that will be orthogonal to that. So if we take the unit vector u, which is equal to 1 over under root 2i plus 1 over under root 2j, the unit vector orthogonal to it will be minus 1 over under root 2i plus 1 over under 2j, because their dot product will be 0. The change will also be 0 in the direction of minus n cap, which is equal to 1 over 2i minus 1 over under root 2j, because the dot product of minus n cap and gradient f will also be 0. ये जो एग्जाम्पल हमने अभी भी की है, इसको जरा हम ज्योमेट्रिकली भी देखते हैं कि ये क्या हो रहा है. तो आइए इस फंक्शन की ज्योमेट्रिकल फिगर देखते हैं और स्क्रीन पर चलते हैं. हमारे पास इस एग्जाम्पल में फंक्शन जो है z इज इक्वल टू एक्स स्क्वायर रूट 2 प्लस वाई स्क्वायर रूट 2 है. इस फंक्शन को ट्रेस किया गया तो ये एक सरफेस बनी प्याला नुमा. एक्स वाई पर पॉइंट हमारे पास 1, 1 है, जिसका कॉरस्पॉन्डिंग पॉइंट z जो है वो भी 1 है. सो इस सरफेस पे जो पॉइंट 1, 1, 1 है, इस पे हम देखेंगे कि किस डायरेक्शन में मैक्सिमम चेंज है, किस डायरेक्शन में मिनिमम चेंज है और किस डायरेक्शन में जीरो चेंज है. ये जो ये हमारे पास जो एरोज नजर आ रहे हैं, इसमें जो ये तिरछा एरो है उसके ऊपर की डायरेक्शन है, इसमें मैक्सिमम चेंज है, और इसके नीचे की डायरेक्शन में ये मिनिमम चेंज है. और ये जो एक कर्व नजर आ रहा है सरफेस के ऊपर, इनफैक्ट ये द प्लेन z इज इक्वल टू 1 और सरफेस का इंटरसेक्शन है. along this curve the change is 0, there is no change. इस फिगर पे आप मजीद गौर करें और खुद देखेंगे आप कि जिस वक्त आप इसको एवेल्युएट करेंगे तो आपको ये पता चलेगा कि मैक्सिमम चेंज किस डायरेक्शन में है, मिनिमम चेंज किस डायरेक्शन में है और जीरो चेंज किस डायरेक्शन में है। आज के लेक्चर में हमने ग्रेडियंट ऑफ फंक्शन को डिफाइन किया और डायरेक्शनल डेरिवेटिव्स की बात की। अगले लेक्चर में हम अपने कोर्स को आगे बढ़ाएंगे और इनको इस्तेमाल करते हुए टेंजेंट प्लेन और उस पे नॉर्मल की बातें करेंगे। उस वक्त तक के लिए खुदा हाफिज।